Okay, in this video we are going to be talking about combinations of functions and composite functions. Don't forget, anything that's highlighted in yellow you need to copy into your guided notes. If you need to pause the video, feel free to pause and then resume the video. And then, why do you think it's important? This should have been answered already, but if not, now would be a good time to answer this question. All right, finding a function's domain. If a function does not model data or have verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. What we do is exclude from the function's domain any numbers that cause division by 0 and real numbers that result in an even root of a negative number. So that's a really fancy way of saying you have to worry that, how do I say this? That the domain will be negative infinity to positive infinity, with a couple exceptions. If you have a fraction, a rational function, so say 3x over x minus 8. So if you have a fraction where you could have potentially 0 in the denominator, that's undefined, you cannot divide by 0. The other possibility is when you have an even root. So if, say, for example, you have the square root of x plus 7, you have to avoid taking the square root of a negative number. So those are the two main scenarios you have to watch out for when you are finding the domain. Pretty much everything else, the domain is going to be negative infinity to positive infinity. All right, so find the domain of this function right here. G of x is equal to 5x over x squared minus 9. So the only time we have to be concerned with a fraction is when the denominator is 0. So what we're going to do is set the denominator equal to 0 and then solve it. We could solve it by factoring this as a difference of squares. Or we could use the square root property. Either way, we end up with positive 7 and negative 7. Now that will give us a 0 in the denominator. So we have to exclude x equals 7, x equals negative 7. We would write the domain in interval notation by going negative infinity to negative 7. Do not include the negative 7. Union, negative 7 to positive 7. Union, 7 to infinity. So what this says right here is basically exclude 7 and negative 7 from the domain. You cannot use those two numbers for x. Algebra of functions. So the sum of two functions, the difference means subtract, the product or multiplying, and the quotient are functions whose domains are the set of all real numbers, common to the domains of f and g, defined as follows. What do we got? Okay, so basically what they're saying here is that if we're trying to add two functions, excuse me, basically this is just two different notations for the same thing. If I have f of x equals x plus 2 and g of x equals x minus 8, let's do 2x minus 8, then f plus g x is equal to my f function plus my g function. That's all that's saying. And then you would simplify it. 3x minus 6 would be the final answer. F minus g works the same way. Don't forget that you would have to put the g function in parentheses, or the second function in parentheses, to distribute the negative. The product, we just multiply the functions. Quotient, we divide. You do have to be careful, though, when we are dividing to make sure that g of x is not equal to 0. Because we cannot have 0 in the denominator, that would be undefined. Okay, so we need to find f plus g of x, and we need to also find the domain of the function. Okay, so what does that mean? So first we're going to take f plus g of x, and that means we're going to take our f function and add, oh, it looks like a typo. This should be g of x. Add x squared minus 1. We're going to add those together. And it looks like combining like terms, we have an x squared, we have an x, and we have a minus 6. So f plus g of x is equal to x squared plus 6x minus 6. So now for the domain. The domain for the f function is negative infinity to positive infinity, so no worries there. The domain for the g function is also, so f, the domain is negative infinity to positive infinity. The g function also is negative infinity to positive infinity. There's no fractions, there's no square roots. So if we add the two together, so f plus g of x, then the domain is still going to be negative infinity to positive infinity, because there's no restrictions here, no restrictions here. That means no restrictions there. That's not always going to be the case. Okay, composite. So I had a professor in college called this the fog function, because that looks like the word fog. This is not a multiplication symbol. This is a symbol that means function composition, and what that means is take the second function and plug it into the first function like this. You take your second function, plug it into your first function. The domain, set of all x such that x has to be in the domain of g, and the g of x, so the y values for your g, have to be in the domain of f. Okay, so x has to be in the domain of g, and then those corresponding y values for g have to be in the domain of f. All right, so let's take a look at an example. We need to find f composed with g of x. So I'm going to take my g function and plug it into my f function. So f of g of x. So f of, so here's my g of x function, 2x squared minus x minus 1. I have to take this and plug it into my f function for x. So that's going to give me my 5, and then I'm going to replace my x with 2x squared minus x minus 1, and then plus 6. Distribute, and combine like terms. minus 5x plus 1. All right. So as a reminder, if x is not in the domain of G, we cannot put it in the domain of f composed with G. Well, there's no restrictions on the G. Okay, so that's no worry. Any x for which G of x is not in the domain of f must not be included as well. Well, if we have these y values, so whatever y values we have, and we plug them in for x, this is not restricted either. So again, no restrictions on this one. Okay. So let's suppose we have f of x is equal to 4 over, okay, so already I can see that we're going to have to worry about the domain because we've got a fraction, we've got two fractions. Okay. So what we're going to do is find f composed. By the way, I don't know if I mentioned this, f composed with G of x is rarely equal to G composed with f. So the order matters. These are rarely the same. It happens occasionally, but that's the exception, not the rule. So let's find f composed with G. So f composed with G is f of G of x, which is 1 over x. So I'm going to take 1 over x and plug it in to my f function. So 4 over, replace my x with 1 over x, plus 2. This needs to be simplified. It's a complex fraction, so I'm going to multiply top and bottom by x. And that gives me 4x on the top. And then if I distribute the x here and there, I've got x over x plus 2x, and this will cancel to 1. So I have 4x, 1 plus 2x would be the f composed with G. Okay, now let's take a look at the domain. All right, so we know that for the G function, x cannot equal 0. So for G of x, x cannot equal 0. Okay. For the f composed with G of x, x cannot equal -1/2. How do we get the -1/2? So if we take 1 plus 2x, set it equal to 0, we get 2x is equal to -1. So there's my -1/2. Okay. So I have to exclude 0 and -1/2. So exclude -1/2 and 0. Oops, sorry, that should be -1/2. Okay, so this says exclude -1/2 and exclude 0. So there you go, there's your domain. All right, what next? I already did that. We already found the domain. Okay, so now we start with a composite function. It's already been composed. We already have one function inside of the other. So what they want us to do is separate it into two different functions, f and g, that would equal f composed with g. Right? F composed with g. So we need an f function, and we need a g function. And the g function has to be inside the f function. So you can either start on the inside or you can start on the outside, whatever works for you. So I'm looking at the outside here. The outside is a square root. So I'm going to make my f function the square root of x. And then for my inside function, I'm looking at the inside. My inside is x squared plus 5. So just to double check, if I were to do f composed with g, I would take my g function here and plug it into my f function, and I would get the square root of x squared plus 5. So it does double check. So here is my f function, and here is my g function. This skill is used a lot in calculus. So just a heads up on that one. You will need to know how to do this, not only in this class, but it is also very helpful, very useful, used a lot in calculus. And your learning reflection.